The coronavirus pandemic has led to shortages around the world. And in the early days of the pandemic, we ran into one particularly concerning shortage. We didn't have enough blood. Blood drives across the country were canceled, leading to more than 1 million donations going uncollected. So when we run low on blood, is there a backup? Not yet, but researchers have been working on a solution for the future by producing blood in their labs. Blood can be complex to replicate because it's made up of different parts. Red blood cells that carry oxygen, white blood cells to fight infection, plasma that carries nutrients and proteins and transports blood cells, and platelets that help your blood clot. A lot of the momentum in the field is with labs trying to grow their own platelets. How do they do that? They use stem cells. Those are cells that have the ability to make other cells. Scientists have previously tried out different types of stem cells, but there was a huge breakthrough in 2006 when a researcher found a way to turn mature cells in the body into a pluripotent stem cell. That is, a stem cell that can create almost any other cell. It's like if you use different kinds of building blocks to make this big castle, then revert that castle back to a single block, and then you can tweak that block, multiply it, and build a completely different structure. This Nobel Prize-winning discovery prompted researchers to change their work so they could use these special cells. So how do you go from stem cell to platelet? First, you need to grow them into what's called a megakaryocyte. It's the huge cell that produces platelets in the body. Typically, scientists take the pluripotent stem cells and activate certain regions of their DNA to coax them into becoming a megakaryocyte. Then, they mix the megakaryocytes with fluid, causing the cells to multiply. And finally, they produce platelets. But they had difficulty producing enough platelets until one research group unlocked a solution. They created a bioreactor. It's like an 8-liter French press, which works by keeping the megakaryocytes moving, and it allows them to produce billions of platelets. In other words, enough for a transfusion. Most of this work is currently being done in labs, but these platelets have been tried out on one human subject in a clinical trial in Japan. Right now, the technology is expensive. It can cost labs tens of thousands of dollars to make one bag of platelets. But researchers have a vision for a more scalable solution: platelet factories. There's hope that in the future, manufactured blood could help deliver critical therapies, support areas of the world where the blood supply runs low, or be used as a backup during global emergencies.